Hello everybody. Now we'll discuss regarding the design of shafts, keys and coupling as per our syllabus, that is the unit number 2. Okay, let us see one by one. Now whenever the word comes, that is the shaft. Now what do you mean by the shaft? What do you mean by the keys and what do you mean by the coupling? We'll discuss all these things in detail. Now we'll discuss that is the design of shaft based on the strength, rigidity and lateral rigidity. Design based on ASME code, that is the American Society for the Mechanical Engineers. That is some standard codes are being written for the design of shafts. Then we'll see the design different types of keys, then how to design the keys, then different types of coupling like a flange and flexible bush pin type of coupling, then rigid coupling, flexible couplings, and we'll try to design all these types of coupling. Now whenever we'll say shaft, now how we can define a shaft? Shaft is defined as a rotating member, usually circular in section, used to transmit the power or motion. Now the word power is the most important, that is the mechanical element which will transmit the power is called as a shaft. The element which does not transmit the power can be called as a rod. This is the basic difference between rod and shaft. Many times we will come across the word of shaft and rod. Now the shafts are further being classified into two categories as shown in the slide, that is the transmission shaft and the spindles. Now a shaft is used to transmit the power between the source and machine. Absorbing the power is called as the transmission shaft. It carries the element like a belt, pulleys, gears, then sockets, different power transmitting elements which is mounted on the shaft. Now these are subjected to the torque, bending moment, axial force and combination of all these things. Then what is the spindle? Spindle is a short rotating member, is called as a spindle, or we can say a short rotating shaft is called as a spindle. Long rotating member is called as the shaft. An axle is a non-rotating member which does not transmit the torque, used to support the machine elements like wheel and the pulleys. Now we are seeing the four different parts, that is the rod, shaft, spindle and axle. Rod does not transmit any kind of power. Shaft is used to transmit the power. Spindle, it is nothing but a short rotating shaft, is called as a spindle. Then an axle is a non-rotating member. It is a non-rotating member used to support the elements like wheels and pulleys. Okay, now it's clear the different classification of the shafts. Then the shafts are available in the standard sizes only. Okay, now these sizes are being taken from the data book. Generally you try to use the PhD data book. Okay, now in the PhD data book you will get a variety of the series of the shaft. Now this series is being developed by using a preferred series. Okay, that is R5, R10, R20, R40, different series are there. Accordingly the shaft sizes are being decided. Then there are different types of materials for the shafts are available. Now ordinary shafts are generally manufactured by using a mild steel, and for high strength in heavy duty applications like a vehicle we'll use alloy steel like a nickel chromium, chromium vanadium, nickel vanadium. Different shaft materials are generally used depending on the strength requirement. Okay, and now what are the materials are there for the shaft are being manufactured by using hot rolling and cold drying processes. Okay, and these materials are specifically designed for the working on the torque, because shaft is mainly subject to the torque means it will use the Flctuating equation, that is T by J is equal to tau by R is equal to G theta by L. Then the shaft design. Now it's clear that is what are the different types of shafts are there, or what are different rotating elements are there, that is the shaft, rod, spindles and axle. Our definition shaft, it is a rotating member Okay, it may generally circular in section, which will transmit the power. Okay, a rod does not transmit any kind of power. A small short rotating member is called as a spindle, and axle is the supporting member only. It will be used to mount the wheels and pulleys. Now we want to design a shaft, means it is a rotating member. Rotating members means it will have a torque. Okay, now shaft is based on the strength rigidity. There are two ways are there to design a shaft. Now first of all, the based on the strength, first further category, that is the design against the static loading. Now if you are using the design against the static loading, that means load is constant, then we can use the maximum shear stress theory of failure, we can use the maximum distortion energy theory of failure, we can use the maximum principal stress theory of failure. Then design of hollow shafts against the static loading, we can use the maximum shear stress theory, then we can use the maximum principal stress theory. Then next one is the design for the fatigue loading, that is based on maximum shear, distortion and maximum principal. That means everywhere maximum shear, distortion and principal theory is common. Then design based on the ASME codes, design based on the rigidity and deflection, design based on the torsional rigidity, and the last one is nothing but design based on the lateral rigidity. Now there is a various design methodologies are there that we'll discuss in the next session. Thank you.